Hi everyone. So today we're going to talk about the TMP 36 analog temperature sensor. So a couple things you probably get right off the bat. It is an analog device, right? So we're going to be measuring analog voltage as opposed to digital signals. So this is more like a potentiometer than it is like, let's say, a button, okay? It's also a temperature sensor, so that's fairly straightforward. We use this to basically convert the temperature, the heat level that's outside, into a voltage that we can then measure. What we say is we say that this particular device, the TMP36, is linearly proportional to temperature. So if you think back to your classes you've had before math, like what do we mean when we say that? So in this particular case, what we're looking at is the idea that this graph varies linearly between temperature and voltage. So the nice thing about this device is that over basically negative 50 Celsius to 125 Celsius, which is more than adequate for what we would want to measure. Right? We look up here, we see that this particular device, the 36, is line B. So conveniently, the graph is pretty linear. So we're not going to have to do a lot of complex math, so we don't have to worry about that. But if you remember back to things with simple slopes and intercepts, basically there's going to be a really simple conversion, and that's what's nice. Now, obviously, if you go past this range, or below this range, you would need some other kind of device, and it doesn't really work. So you can kind of see that this particular one we're looking at here is, I don't know, like we could look in the chart, probably negative 40 something, and fairly linear up to about 125 Celsius. So pretty good, pretty good. We're all satisfied with that. Okay. Now, one of the things that's really important, and we've talked about this in class before, is being able to understand the data sheet. So what I'd like you to do is pause this for just a moment and look at the data sheet. The link is in the notes, and just skim it for pick 30 seconds and figure out what do you think is the most important things you'd want to pull out. Now, you look at the data sheet, it's going to be pages and pages. Don't read it. I don't expect you to go through and read it unless you're really, really curious. But if you skim it very quickly, what are the things you as the user, you building a little device, what do you need to know? Okay. So what I want to do is just pull out a couple of the things that I think are really important. And so whether you're using this sensor or another one, you want to look for. So a couple interesting things is the voltage, right? So this is great because we know that we have a 3.3 volt device. That's what it's going to operate at. So that's good. So we're within the range that we want. Okay. Now this is really important. This scale factor that has to do with the line that we just saw. We'll come back to this one in a second. Okay. So don't worry too much about it. Here we go. The accuracy. So this is good, right? So if you're building a device for inside your house, this is probably good enough. If you're building something with complex chemical reactions or something like that, that may not be good enough, okay? We kind of skim down here. We look here, we see, here is the range. Well, we saw this on the last graph, but this is another thing that you'd want to look at. You would want to know what is the range of temperatures. So we have the range of voltage, and now we have the range of temperatures. Perfect. So we kind of know how to build that. And then the other thing that's really, really, really important, I cannot emphasize this is enough. I'm going to put little stars here, say it's super important, is this picture. So this right here is the TMP 36 device that we're going to be looking at. And what I want you to note here is that it has 3 pins. Now, VS is going to be 3.3. That's what VS stands for, voltage source. So this is my 3 volts. Pin 3 is my ground. And pin 2 goes to my analog input. Now, the most important thing on this picture is right here. This is the bottom view. So when you look at the device and you're trying to figure out which pin is power and which pin is ground, you have to do basically the opposite of what you think you would do, which is you're not looking at the device top down. You need to flip it up so that the pins are in the air when you think about which one's the power and which one's the ground. I say that this is very important. Again, here's a second star. Because this is probably the component we use in the class the most, that it's easiest to wire backwards. It will get very hot, it will melt the plastic, and it will be very, very hot to touch. So, quick word of warning. Be very cautious, make sure you wire it carefully, if you're not getting output and it starts to overheat, or you start to smell something, or you're getting weird reactions, unplug the USB and don't touch the TMP36 yet. Let it cool down. Otherwise, it would burn you. You wouldn't. It would be unpleasant, right? And it happens. I've done it before. I've smelled plastic burning. So just be careful with that, please. Okay. The next thing. This is also very important right here. So here's what we're looking at. Okay. This tells us the calculation. So what we need to know is the following. There is an offset of 0.5 volts. So what that means is whatever we read, we're going to have to subtract 0.5 volts. And then there's a scale, right? Remember the graph kind of looks like this. Here's temp, and here's voltage, right? Like this, okay? So this is going to be the scale factor. So with these two numbers, we are now able to convert any voltage into a temperature. Okay. So let's just look at this for just a second. So here's our basic conversion, right? So looking at that chart, we've got 500 millivolt offset, 10 millivolts per degree Celsius. So what I want you to try is just take a second, is if you read 1.2 volts, okay? So you're reading your device 1.2 volts. What temperature in Celsius is that? And then what temperature is in Fahrenheit is it? So give yourself just a second, think about that. Okay, so let's talk about it. We'll work it out together. Okay, so we know that we're reading 1.2 volts, okay? So that's what we're starting with. Now, we have an offset. So our offset is 0.5 volts. So what that means is we take our 1.2 volts and we subtract 0.5 volts, right? And now we're left with 0.7 volts. Perfect, okay? Now we have to look at our scale, which would be our slope, right? So our scale was 10 millivolts per, and we're going to say 1 degree Celsius, okay? So we know that this would be 10 millivolts is actually going to be 0.01 volts per degree Celsius. And so here we go. We say 0.7 volts, right? You can, however you want to do this, however you think about this kind of analysis, dimensional analysis, sometimes we call it, right? So I'm going to multiply that by, I've got my 1 degree Celsius divided by 0.01 volts. By the way, this just came from here. So I got that. So I do this math. The volts cancel. Right? And then what I'm left with is 70 degrees Celsius. And if you want to do the conversion to Fahrenheit, the formula is on the screen, on the previous slide. And so basically, if you want to check your math, that ends up being 159 degrees Fahrenheit, which is quite hot. Okay, so this is basically the calculation that you're doing inside the argon when you get the voltage. Now, the one thing that I didn't do that I want you to just kind of keep in mind is that the argon, right, for an analog read, right, remember that the analog read is not going to be voltage. It's going to be your ADC, your analog to digital conversion value. That's going to go from 0 to 4095. So you have to remember, like we talked about last week, and I'll leave this one to you, if we've got this, how do we get this to a voltage? Okay? So remember, basically, if you want to think about the path, if you want to go the full path, it's going to be, I have my analog to digital value, right? That's going to get converted to a voltage. My voltage is then going to get converted to a temperature in Celsius. And then if you want, you would then do another math to convert that to temp Fahrenheit. Okay, they're all fairly straightforward calculations, but nevertheless, we just got to be careful about it. Okay, and then so picking up with this, quick thing to remember: if you're new to C++, this is really, really, really important. When you do division with integers, right, int and int, you throw away the decimal. So it's not like Python. This is basically an integer division. So 3 divided by 6 is going to be 0.5, but because they're integers, we throw away this, and you just get 0, okay? So even though the result is a float here, the answer is going to be 0. So remember, we have to always do this, call this casting or converting. So when you're doing math here, for this example, make sure you do it that way. Okay, last picture, again, just cannot emphasize this enough. This is the upside down picture, right? So when you're wiring this, it's kind of like you've got the, let's see, I'm not really all that great at drawing here. I've got this picture here, okay? I'm gonna look at it like this, and here's my 3 pins, okay? That's my sensor. So that's kind of what you're looking at. So when you're wiring it, just be careful. Don't get these switched.